All right. So, today we are going to focus on surface area and volume. But we're going to start with surface area first. So when we look at surface area, first thing we want to do is we're going to draw our bottom of our box. Okay, so this is an 8 by 7 bottom to our box. So then our front face and our back face come down here, where this is 2, and that's 2. So these are 2 by 8s. Then we have the sides of our box, and this is called a net figure, and we need to draw a net figure for our surface area, because what we're going to do is, and then we have to lid to our box. And that's another 8 by 7. So when we find surface area, what we're doing is we're trying to find the areas of 1, 2, 3, 4, 5, and 6. Now, A1 is actually equal to A6. These are the same rectangles. Same with A2 and A4, and then A3 and A5. So once I find one of them, I know both of them. And because all of these are rectangles, we're going to do length times width for all of these shapes. So if I look at this one, it's the same as that one. And then we'll turn this one and make it the same as that one. So that's A3 and A5. And then the last one will be A2 and A4. Okay, so when we start with this, we're going to do the red one. So in that case, the L is going to be 8 and W is going to be 2. So this is going to be 8 times 2, which is 16. For the green, we're going to do W as 2, but the L this time is going to be 7. So we're going to do 7 times 2. And for the big one, we have the length and then the width. And that's going to be 8 times 7, which is 56. Now, A1 plus A2 plus A3 plus A4 plus A5 plus A6 will give me surface area. Okay, so now remember we already color coordinated them, so we're going to do 2 and 4 being green. We're going to do 3 and 5 being blue, and then 1 and 6, wrong red, I must pick this one, being that one. Okay, so now when we plug our numbers in, A1 16, A2 14, A3 56, A4 14, A5 56, A6 16. And then once we combine all these, that becomes our total surface area. So let's do, let's see, 16 plus 14 plus 56, 86, and then we'll times 86 times 2. This guy. What up, Mo? And I get 117. So when we go back here, we know that this is 107. No, that was right. What did we? What was it? 172? That's what it is. So, do that. 172. Sorry. All right. So that becomes our first problem. Moving on. So, moving on to our second one. We have a trapezoid. Okay. So for this one, when we draw our net figure, once again, we're going to have a rectangle again as kind of our base shape. And that's the bottom of our shape. So we're going to have a trapezoid here. And we're going to have a trapezoid here. Then we're going to have our two sides that fold in for the trapezoid. And then we have this thin one on top for the top of the trapezoid. So when that's the case, we have the tops as 7. And what those tops become is this. Let's highlight it. This right here becomes that piece right there. So, I don't know, maybe I should have made it a little bit longer, but that's what we're looking at. Let's see if we can erase this. Okay. So we just have to reconnect. So then this should be 7. Then 10. So this is 10, that's 10. 7 is across, and then this is going to be 21. As we look at the big bottom, so we talked about this in class, it is the distance between our two base shapes. Our two base shapes are the trapezoids. So the two highlights are the trapezoids, and the distance between the two base shapes, that's what becomes 21. So this is 13 down here, and it's 13 up here. And then we need a height for our trapezoid as well. And that's going to be 6. So we have a base 2 of a trapezoid. We have a base 1 of a trapezoid. Same thing up here. Our height is 6, but our base 1 is 7. Our base 2 is 13. Then we have a 10 by 21, and this is a 10 by 21. So looking at this again, we have the inside. We have our trapezoid and our trapezoid. Okay. Then we have one of the sides that folds up for the side of the trapezoid. We have the other side that folds up for the trapezoid. And then we have the top of the trapezoid, but the top of the trapezoid is actually different than the bottom because it's obviously thinner on top. It's a thinner rectangle than it is on the bottom. So in that case, we have, oops, where'd my pen go? There we go. Erase that mark. So we've got, I don't want to change this. We've got an A1 and we have A2. So A1 is equal to A2. Okay. And that is going to be 1/2 base 1 plus base 2 times the height. Because the area of a trapezoid, that's the formula we have to use. So we're going to have 1/2. Our base 1 we said was 7. Our base 2 is 13. And then our height is 6. So when we do 7 plus 13, we get 20. Half of 20 is 10. 6 times 10 is 60. Then we can do A3 and A4 is length times width, which is going to be 10 times 21, which is 210. And then A5 is its own right. And that's going to be 13 times 21. And then A6 is going to be length times width, and that's 7 times 21. So when we do 13 times 21, we have 13 times 21, 273. And then 7 times 21, 7, 21, 147. And then we're going to do A1 plus A2 plus A3 plus A4. It's a terrible plus sign. Plus A5 plus A6 equals the surface area, because we need to add all of these together to get our surface area. So when we do this, A1 and A2, these are both 60. A3 and A4 are 210. A5 is 273, and then 147. So 60 plus 60 plus 210 plus 210, 273, 147. $960. So then this becomes 960 is our surface area for this figure. All right. And let's slide this over just a tad so we can see the surface area over here. Drop it just a little bit. Okay. All right. So we can see A1, A2, A3, A4. All right. So there we go. We draw our net figure. We find the areas for each individual spot. And this was A6. All right. And then add them all together to get the surface area. Okay, so last example that I want to do for surface area. What happened to, oh, here it is. All right, so our net figure for this one is definitely a little different. Okay, so we have two circles, or circle-ish, I guess. No, I don't know what that is. Let's try that again. Okay. So when we look at this, what happens is we have a circle, and our circle has a radius that is 7. And as we go around the circle, okay, so we're traveling around this circle, we are legit finding the same thing from here to here. Okay? So if we want the length of this rectangle, we actually need to find the outside of the circle. And the outside perimeter of a circle is what we call circumference, and that's 2 pi r. So this is going to be 2 times pi times 7. So L is going to equal 14 pi, which is equivalent to 43.98. So we're going to 43.98. So that's our length. That's our length. Now our height right here, from one base to the other, let's use a different color. So our base from one to the other is going to be 11. So if I want the area of the first one, it's going to be length times width, which is equal to 2 pi r times 11. That's 2 pi times 7 times 11. Now we did 2 pi r and got 43.98. And we're going to multiply that by 11. And that's going to give us our overall area for number 1. Okay, so when we do that, 43.98 times 11, 483.78. 483.78. 483.78. Okay, so that's our area for the outside rectangle. Now, for the circle, area 2 and area 3 are going to be the same thing. Pi r squared, which is pi times 7 squared, because the radius from the center out to any spot on the circle is going to be the same. So that's going to be 49 pi, which is equivalent to 49 pi 153.93. 153.93. Okay, so now if I need A1 plus A2 plus A3 will give me my surface area of this can. So that is surface area. So we're going to do 483.78 plus 153.93 plus 153.93 equals surface area. Now, 483.78 plus 53.93 plus 153.93. 791.64. And that's our surface area. So these are our 3 surface area problems from the homework. Obviously, you can pull more surface area if you want. I think there was more, we're due 4 problems, so there's one we didn't do, but that's okay. So I'm going to stop recording.